True or false? 4 raised to the power 3 equal to 4 times 3. I'm going to give you 10 seconds to think about the problem. The answer is false. 4 raised to the power 3 is not equal to 4 times 3. 4 raised to the power 3 equal to 4 times 4 times 4, which is equal to 64. True or false? 0 divided by 0 is equal to 0. I will give you 10 seconds to think about the problem. The answer is false. 0 divided by 0 is not equal to 0. Okay? 0 divided by 0 is equal to undefined, not 0. True or false? Open parentheses, negative 3, close parentheses, raised to the power 2 equal to negative 3 raised to the power 2. Is it true or false? I will give you 10 seconds to think about the problem. So it's false, okay? They are not equal to each other. So negative 3 whole square means negative 3 times negative 3, which is equal to positive 9. Negative 3 raised to the power 2 means negative 3 times just 3. So that's going to give us negative 9. As you can see, or false, 2 over 3x equal to 2 over 3x. What do you think? True or false? I will give you 10 seconds to think about the problem. So the answer is false, okay? 2x over 3 is not equal to 2 over 3x, okay? However, you can write this as 2x over 3. 4 over 3 divided by 2 equal to 4 divided by 3 over 2. I'll give you 10 seconds to think about the problem. So it's false, okay? They are not the same thing. So let me show you the work. Keep, change, flip. Think of 2 as 2 over 1. Think of 4 as 4 over 1. Okay? So keep, change, flip. Keep, change, flip. So that's going to be 4 over 6 or 2 over 3, 8 over 3. X square equal to 2 over pi. X is equal to square root of 2 over pi. Is it true or false? I'll give you 10 seconds to think about the problem. So the answer is actually false, okay? And I have made 2 silly mistakes. So I forgot my plus minus sign. So don't forget your plus minus sign. And I'm also missing radical sign on top of pi, okay? So the answer is going to be x equal to plus minus square root of 2 divided by square root of pi. Or you can also write this as plus minus square root of 2 over pi. If 3 over 4 equal to 2 over x, can you solve for x? I'll give you 10 seconds to think about the problem. So we can apply the butterfly method to solve this problem. So I'm really bad at drawing, as you can see. So 3 times x equal to 3x. 4 times 2 equal to 8. So 3x equal to 8. How can we get rid of this 3? We can divide both sides by 3. So x will be equal to 8 over 3. Let's talk about dividing fraction. 4 divided by 3 over 2. Can you solve this problem? I will give you 10 seconds. Okay, so the best way to solve this problem is using KCF. That means keep, change, and flip. Okay, so keep the numerator, that is 4. Division changes to multiplication sign, and we are going to flip the denominator too. So 2 goes on top, 3 goes in the bottom. So 4 times 2 is equal to 8 divided by 3. 1 over x plus y equal to 1 over x plus 1 over y. Is it true or false? I'll give you 10 seconds. So the answer is actually false, okay? They are not the same thing. They are not the same thing. So 1 over x plus 1 over y can be written as y plus x over xy. As you can see, I have already shown you the work. X is equal to 1. What is f of 0? Well, f of 0 is going to be 1. What is f of 1? F of 1 is also going to be 1. What is f of x? F of x will also be 1. What is f of x plus h? That's also going to be 1. Okay? Why? Because we do not have any x term here. We do not have any x term. So no matter what's the input value, the output value will always be 1 for this specific problem. Okay. B over c equal to a over c plus b over c. Is it true or false? I'll give you 10 seconds, okay? So yes, the answer is true. Let me show you the work. A over c plus b over c. If the whenever you add fraction, if the denominators are the same, you can actually add the numerators. Okay, so a plus b, which is equal to a over c plus b over c. Can you add this fraction 1 over y plus 1 over x? I will give you 10 seconds to think about the problem. If you want to add or subtract any fraction, you need to make sure the denominators are the same. So we are going to multiply top and bottom by x, top and bottom by y. Since their denominators are the same, we can add the numerators, okay? So again, x times y is equal to y times x. So they are the same thing, okay? So x, y, their denominators are the same. We can add the numerators. When you subtract this fraction, 1 over y minus 1 over x, I will give you 10 seconds to think about the problem. If you want to add or subtract any fraction, you need to make sure you have the same denominator, okay? So I'm going to multiply top and bottom by x, And here I'm going to multiply top and bottom by y. Remember, x times y and y times x are the same thing. So that means we have the same denominator. So I can write xy. So if the denominators are the same, you can add or subtract the numerator. In this case, we're going to subtract. So x minus y. And can you multiply this fraction 1 over x times 1 over y? I will give you 10 seconds to think about the problem. So when you multiply fraction, what you do, you multiply the top numbers, okay? So 1 times 1 is equal to 1. And then you multiply the bottom numbers. In this case, we have x and y, so x times y, xy. Can you divide this fraction 1 over x divided by 1 over y? I will give you 10 seconds to think about the problem. We're going to use the KCF method. So that means keep the first term, change division to a multiplication sign, and flip the second term. So y goes on top, 1 stays in the bottom, y over 1. Multiply the top number, y divided by x, y divided by x. So multiply the top number and multiply the bottom number.